Now we will see how this SpyGuard part of the Cotter Joint assembly can be modeled. For this SpyGuard part, okay, that is part number 2 of the Cotter Joint assembly, they have given again front view and the top view. As it can be seen in the front view, the left side of the SpyGuard is having diameter of 30 mm, and on the right side there is a rod which is having a diameter of 25 mm, and this portion will be called as the collar of the SpyGuard, which is having diameter of 38 mm, which can be read in the top view. Okay, so with respect to this SpyGuard, this portion will be the rod portion, this is the collar portion of the SpyGuard, and this is the SpyGuard end portion of the SpyGuard. Okay, the SpyGuard end portion is having diameter of 30 mm, the rod is having diameter of 25 mm, and the collar of the SpyGuard is having diameter of 38 mm. Okay, so since there is no inner diameter given with respect to the SpyGuard, this clearly indicates that this SpyGuard is a solid cylindrical component. It is not a hollow cylindrical component, it is a solid cylindrical component. So therefore again, since it is a cylindrical component, we can use the revolve option. You can use revolve option, or you can also use the extrude option. Okay, whichever you feel we can adopt it, but again here also I am going to use the revolve option. So whenever we want to use the revolve option, we will create the profile which is present on one side of the axis of the component. In this case, this is the axis of the component. With respect to this axis of the SpyGuard, the upper profile will be drawn. That is, from here, choosing this as the starting point, I will draw one vertical line first, then horizontal line, then vertical line, then again horizontal line, again vertical line, then again horizontal line, okay, then vertical line, again I will come back to the starting point. So I am going to use this as my starting point for creating the upper profile of the SpyGuard with respect to its axis. So what I do now is I am going to close this SpyGuard. Okay, then I am going to create a new part now. Okay, so I am going to change the background to plain white. Okay, then I will select the front plane. I will go for the sketch command tab. There I am going to use the sketch command, and then I am going to use the I am going to select the line command here. Then okay, so I am going to choose this particular point as the which one starting. This point will be selected as what? Starting point. From this starting point I will draw one vertical line first. So therefore my starting point will be selected as the origin here. Then I will draw one vertical line. So then what I do is I will draw this horizontal line from here to here. Okay, horizontal line will be drawn. Then again vertical line will be drawn, small vertical line. Okay, so then horizontal line will be constructed. Okay, like this. Then again vertical line will be constructed downwards up to somewhere here. Okay, so try to draw only the rough profile. Okay, no need to worry about the dimension, which can be added later. So then again draw one vertical line here. Okay, again come back to the starting point. Okay, so this completes the creation of the upper profile of the SpyGuard with respect to its axis. So you need to remember that in this case this particular line, okay, from here to here represents the axis of the SpyGuard. So now it's the time for adding the dimensions. So first what I do is I am going to so they have not given overall length of the SpyGuard. So what I do is I will go for adding the dimensions, and one you need to again observe here, similar to the socket, they have not given the length for the rod portion of the SpyGuard here. So it will be suitably assumed. So what I do now is I am going to say take smart dimension. So this particular line represents the length of the rod portion. So as it is not given, I am going to use it as 20 mm. Okay, then this particular line represents the collar thickness. So this collar thickness is given as how much here? 10 mm. So this will be added up. This will be added. Then what I do is they have given, so this 19 mm and this 35.5 and this 19 are will corresponds to the which one? This 19 and this 19 actually corresponds to the location of the Cotter hole, and this 35.5 actually indicates the width of the Cotter hole along the axis of the SpyGuard. Okay, exactly at the middle of the SpyGuard, what is the Cotter hole width? Okay, because the Cotter hole width is varying from top to the bottom. At the middle it is 35.5. Okay, that is what they have given here. So therefore what I do now is I need to give the overall length first. So overall length means from this from here to from here the distance should be 19 plus 35.5 plus 19. So therefore I'm going to add that one now. So from here to here the distance should be given as 19 plus 35.5 plus 19. So as it is given in the drawing, I am entering the values. Okay, so it will take as 73.50. Okay, so then what I do now, it's the time for giving the diameter. So I will give the smallest diameter first. So smallest diameter here in this case is 25 mm. So therefore, and it corresponds to this line. So here diameter is nothing but we have to give, since we are creating only half of the profile. So we have to give the radius values, that is 25 by 2. Okay, so then next higher diameter value is 25, then we have 30, here 38. So next higher diameter value is 30. So therefore that can be added now. So it should be how much now? 30 divided by 2. Okay, so then I am going to add the collar diameter. So collar diameter is can be seen in the top view. Here it is 38. So therefore from here to the axis line, that is, so it should be how much now? It should be 38 by 2. So 38 by 2. So now you can see the sketch is fully defined. All the entities of the sketch are turned to black color. So therefore this completes the creation of the sketch in the front plane. So then I am going to bring this sketch in the isometric view. Okay, so now the sketch is in a isometric view, and you can select the front plane and you can verify whether you have created the sketch in the front plane or not. Okay, so once it is verified, then I will select the sketch one again in the feature manager tab. Then I will go to the features tab, and there I am going to use the revolve option. Click on this revolved boss option. Now again, since we have not created the axis, it is asking for axis of revolution. So which should be the axis of revolution in this sketch? This long horizontal line should be the axis of revolution. Select it. Okay, automatic, and go for adding the material for 360 degree. Then click on OK. So we have got the initial draft of the Spygott model. Okay. Is it not? So, but if you try to keep it in front view now, and if you turn on the hidden edges, okay, so only difference now with this front view. Okay, so if you try to compare this front view given in the part drawing sheet with the front view that we have obtained here, okay, so we cannot see any lines somewhere here. So in this zone there is no lines appearing, means so okay, so this tapered line here and this straight line which corresponds to the which one? Which corresponds to the Cotter hole. Okay, so you can see in the Spygott also we have to make the Cotter hole of 7.5 mm thickness, and width of this Cotter hole should be 35.5 along the axis. Okay, or on the axis. So therefore again we need to make Cotter hole in the Spygott also. Okay, so in order to make the Cotter hole in the Spygott, so what I do now is I am going to bring back this model to solid form, and I'm already the model. I will keep the model in isometric view. Then I will select the front plane, because in the front plane we have to on either side of the front plane we have to cut the material. Okay, so that we can get the Cotter hole. Okay, so therefore in order to get that Cotter hole now, I have selected the front plane. Then I will go to the sketch tab. There I will select the sketch command. Okay, and I'm going to keep this in again front view. Okay, so now what I do is I will select line command now. So I'm going to choose this as my starting point. I will draw one vertical line here which represents. So this dashed line actually represents the right edge of this Cotter hole, or the right face of the Cotter hole. While this particular tapered dashed line here represents the which one? Represents the left face of the Cotter hole. Okay, so therefore what I do now is I go for drawing one vertical line first. From somewhere here I will draw one vertical line. Okay, you can draw from the top edge here, otherwise I will draw it from somewhere here. Okay, then I will draw one horizontal line, then I will draw one tapered line up to somewhere here, then up to here. Once this is done, what I do is first step I am going to select this particular line. Okay, or before to that I am going to select the midpoint of this right edge. Okay, or the right line, that is I am going to select the midpoint of this particular line, and I will select the origin by holding the control key. Now I have selected 2 points which can be seen here, and I am going to bring these 2 points on the same horizontal line. So the purpose of doing this is this particular right line is equally distributed above the axis and below the axis. Okay, is that clear? So then what I do is I will select this top line and this top edge here. Okay, of the Spygott cylinder, Spygott end cylinder. Okay, so then once this line 4 and this edge is selected, I am going to make them as collinear. Is that clear? So now within this profile we have to cut the material. You can see, okay, for this profile we have to cut the material, and we have to cut the material on either side of the sketch. Okay, so again I will I will bring it to front view. Now I will go for adding dimensions which are given here. Okay, so exactly at the middle this Cotter wall should have width of 35.5, but before to that the right edge of this Cotter wall should be at a distance of 19 mm from this collar left face. Okay, from the collar left face the right edge of the Cotter wall should be at a distance of 19 mm. So therefore I will select smart dimensions. I will select this one and this line, and this value should be how much now? 19. Okay, similar to this now this distance should be how much? 19. We can give this later, okay, or there is no need to give this one, because anyway we are going to define width of the Cotter wall at the axis. So what we do, so in order to define the width of the Cotter wall along the axis of the spy guard, what I do, I will create one more line now from somewhere, from this midpoint to somewhere here. Okay, so then what I do is I'm going to bring this particular point. I will just check whether this particular point and this particular point are horizontal. So define them. Okay, so then what I do is I'm going to make this line as for construction purpose. Okay, I have made this line which is representing the axis of the spy guard as axis line now. Okay, so I converted the solid line to the axis line. Then I will select the smart dimension. I am going to give this value now as how much now? 35.5. So this should be given as 35.5. Okay, so this is the width of the Cotter wall along the axis of the spy guard. Once this is done, now you can see in this created sketch we have only one entity appearing in blue color, that is this tapered line. You can see now, okay, we can vary the slope of this particular line. Other than that, we will not be able to move any other entity of this sketch. Only we can rotate this particular line. So what we can do now is we can go for defining how much width should decrease when we move from top to the bottom. As the taper of this edge is given as 1:30, the meaning is that when we move from this top edge of this spy guard end to the bottom end of the spy guard end here, okay, from top to the bottom when we move, okay, so the width of this which one? The width of the wall should decrease. How much it should decrease? For every 30 mm, 1 mm should decrease. Now what is the distance from top to the bottom? It is 30. Therefore, okay, so from top to the bottom, okay, when we move, 1 mm width has to decrease. So how to define that? So I'm going to select the top end of the tapered line, and I'm going to select the bottom end of the tapered line, okay, by using the smart dimension option. Then between these two selected points, I'm going to define the horizontal distance. So what is the horizontal distance now? From top end to the bottom end, what should be the decrease in width now? It should be 30 by 30 actually. Okay, so that is, it will come as 1 mm. Okay, so once you enter this distance as 1 mm, then okay, you can see this is tapered line with 1 mm decrease in width when we move from top to the bottom of the spy guard end. Okay, so once this is done, we can you can see the sketch is fully defined here. Okay, the sketch has been fully defined. I will come out of the sketch now. I am going to keep this in isometric view. Okay, and it is in the front plane. Now I will go to the features tab. Then I will go for extruded cut. Okay, I don't want to cut the material on one side of the sketch. So we need to cut the material on both the sides of the sketch created. So I will go for using mid plane option here. Then what should be the Cotter wall width now? Sorry, Cotter wall thickness. The Cotter wall thickness should be 7.5, which can be seen in the top view. So therefore, I am going to give this as 7.5 here. Okay, and then give it OK. So now, if you keep it in top view, you can see the Cotter wall. Okay, but the left face, this left face, okay, and this right face of the Cotter wall are flat here, but as we can see here in the top view, okay, so the left face is actually curved surface, and the right face of the Cotter wall is also curved. Okay, so it is actually curved surface. So therefore, we need to add fillet there. So in order to add the fillet, what we have to do, similar to how we added fillets in socket part. Okay, so we go for features tab. We go for selecting the fillet command. Okay, so I will select the fillet command. Okay, I will select the fillet command. Once this fillet selection menu appears here on the left side. So here we have to select items to fillet. So which items to fillet now? Select this vertical edge, but now the fillet radius is more, it is taken as 10 mm, but what should be the fillet radius here? It should be half of this thickness, that is 7.5 by 2. So I'm going to give this fillet radius as 7.5 by 2 here. Okay, then so this is right now we have selected only one edge, but same thing has to be done for this particular edge, and we are doing multiple edge selection. So multiple edges can be selected simultaneously for filleting. So select all these 4. So face has been selected. Once the face selects, so you can right click on that, you can delete it, then you can go for selecting the edge again. Okay, so therefore you can see now 4 edges have been selected here, and I'm going to click on OK. So I'm going to bring this in isometric view. Now I will keep it in top view. So you can see now, okay, the left face and right face of the cutter hole has been filleted, means has been rounded now. Okay, so you can see it is matching now, and now here you can add fillet. Okay, so it looks like there is a fillet here, there is a fillet here. Okay, there is a fillet here. These fillets can be added now. Okay, so go to the fillet again. So you can select this circular edge here. Okay, unless otherwise mentioned, the fillet radius should be 3 mm. Then select this particular circular edge, and this circular edge can be selected. Then click on OK. So this is how it looks. Okay, but there is no fillet provided here, so you should not give. So fillet has been given here, fillet is given here, and fillet is given here. Okay, so therefore I'm going to keep it in isometric view. Before that, let me take the front view of this, and let me turn on the hidden edges. So this is how it looks. Now this is exactly same as the front view given in this part drawing sheet for the spy guard. Okay, so this completes the modeling of which one? Modeling of the spy guard. So bring the model to the isometric view, and then save this as part 2. Okay, spy guard. Okay, then you can close this which one? Graphics window. Now we will go for creating the third part of the cotter joint assembly, that is the cotter.